This is the last in the series of videos on sample force problems for AP Physics C. I'll be using these as an assignment for your online days. And just to refresh our memory, we've got this board of equations. Remember Newton's second law, F net is equal to m tot, or m system, times A. Deciding what system to talk about is going to be important in this last problem. Coefficient of friction is equal to force of friction over force normal for kinetic friction, and the coefficient of friction is greater than or equal to the force friction over F normal for static friction. I'm not going to be using friction in this example, although you can imagine it would be pretty easy to add it in. Finally, the gravitational force of an object is equal to mg near Earth, and this one we'll use later in the semester. It's the gravitational force between two objects anywhere in the universe. All right, one thing to think about with this last video is there's a separate keyword than last time. Remember, if you'd like a prize, make sure you tell me the word in class. The word for this video is mayonnaise. Delicious, delicious mayonnaise. Thank you. All right, sample number 4, and that's Mr. McChesney who's going to talk to me about mayonnaise. Determine the tension in each of the light strings, or in each light string for the scenario shown. In this example, we're going to assume no friction. So we've got 3 objects, blocks A, B, and C, and I've given them masses. You can imagine that the College Board might give you M1, M2, M3, or they might put that in terms of M1, 4 times M1, 2 times M1. Either way, you could solve this with variables or with numbers. At any rate, when we look at this, the whole system is being pulled by a hand. That's supposed to be a hand. Sorry about that. And it's accelerating to the right. Because these are all attached to each other, they experience what's called an acceleration constraint. Now what that means is they obviously are all accelerating at the same rate, at 2 meters per second squared. The thing you have to think about is they have different masses. And students tend to think that objects that are connected are going to have different accelerations but the same net force on them. In fact, if they experience the same acceleration but have different masses, they'll have different net forces on them. So if we go back to that Newton's second law, if I have 2 meters per second squared for acceleration and this mass is 10 kilograms, I know that the net force on block C has got to be 20 newtons to the right. The net force on block B has got to be 40 newtons to the right, and the net force on block A has got to be 10 newtons to the right. That can be very helpful for solving things. When I go through and solve this particular problem, I'm going to solve either T3 first or T1 first, because I think I can solve it very easily using Newton's second law and what I just talked about. So it's also going to be helpful to pick a system. So in this particular case, I'm going to pick this whole group of all those 3 objects as my system. And I'm going to solve for T3. So when I look at this, once again, F net, and I'm going to call this M system times A. Well, if we think about this, if this is a frictionless system, the only thing causing a force on that system is the tension in rope 3. So I could rewrite this as T3, and the mass of this system is going to be 10 plus 20 plus 5 kilograms. I don't know why I did it in that order. And the acceleration is 2 meters per second squared. So I've got 10 plus 20 plus 5 kilograms, that's 35 kilograms. Multiplied by 2 meters per second squared, or 2 newtons per kilogram. And that tells me that T3 is going to be equal to 70 newtons. If you take a moment and think about this conceptually, it might actually fool you a little bit. So I've got 70 newtons here, and it's attached to this 10 kilogram object. Some people might think that the tension in object 2 would be greater than that because it's pulling on a 20 kilogram object. But if we think about this a little bit differently, we could realize that tension 2 is pulling only blocks A and B and accelerating them at 2 meters per second squared. Similarly, tension 1, I gotta find another color here, I'll try red, is only acting to accelerate block A, the 5 kilogram block. I'm actually going to do this one next, and I'll explain to you how I could solve this one. So I'm going to apply Newton's second law again, but now it's to a new system, only with block A. So F net equals M system times A. The acceleration is the same in all these problems because all the blocks are connected to each other. So in this case, F net is equal to T1. So I can say T1 is the mass of the system, that's only 5 kilograms, multiplied by 2 meters per second squared. So T1 is equal to 10 newtons. Now this might be something where you say, well, that makes sense. 70 newtons is acting up here, 10 newtons is acting only on that last little one. But you still might be confused about how to get T2. Now, I'm going to show you how to get T2 probably a couple different ways. I'm going to have to use the space here because this is as far as I can go on this board. So I'm going to have to erase what I did for T1 and T3. I'm going to save those values so I don't forget them. T1 is equal to 70 newtons. T3 is equal to 10 newtons. Or pardon me, let's flip-flop that. T1 is equal to 10 newtons. And T3 is equal to 70 newtons. All right, erase we go. Ugh, that did not erase very well. That's what you get for buying markers on sale, I guess. All right, I'm going to switch, and we're going to think about B here. Now, there's a couple ways you could think about this. You could think about this the way we did T1 and T3, and just simply say F net, which would be T2, is equal to M system, which would be 25 kilograms here, times 2 meters per second squared. Or we could focus on block C. I'm going to switch to block C and think about that. That's going to be in purple. So notice that either the green circle here or the purple oval here actually cross, the system barrier crosses this T2, or tension for object 2. That means we can solve for it. The only way we can solve for a tension is treating it like an external force, which means we've got to design a system where that tension crosses our system boundary. So I could solve it a couple ways. I'm going to solve it like I did with this purple oval right here. So I'm going to start back again with Newton's second law. F net is equal to M system times acceleration. Since acceleration is to the right, we're going to think about the fact that things going to the right would be positive, things going to the left would be negative. So in this particular case, I've got two forces acting on block C. T3, which would be pulling to the right, and T2 would be pulling back to the left. So I'm going to say here T3 minus T2. The mass of this system is 10 kilograms. And the acceleration of the system is 2 meters per second squared. Notice that's a positive number. T3 minus T2 should give me a positive number as well. All right, I know everything here except for T2. Because I know T3 already, I solved for that. So I could say 70 newtons minus T2 is equal to 10 times 2, which is 20 newtons. So if I move this around, I'll get 70 minus 20 is equal to T2, because this is a negative T2, and I'm going to move that to the other side. So I can say that 50 newtons is equal to T2. Note that if we go back and look at this green circle here, I could do the same thing that I did with the other ones. F net M system times A. For this green circle here, the system is 25 kilograms. F net would be T2. And you've got 2 meters per second squared. And hopefully you can see already 25 times 2 is going to give us 50 newtons. Because physics works either way. So a really powerful thing to understand is if you understand your physics properly, you can take many different methods to solve a problem and you'll still get the same answer. That also includes if you're thinking about completely different methodologies for some problems, like using momentum or conservation of energy or kinematics. They should give you a consistent result. Thanks.